So this is what you want me to do. I'm going to do it for you. This is a scene from Netflix show Space Force. Spoiler alert: boots on the moon. Of course, they're going to get on the moon. So this is near the end, but they're on the moon. So if you haven't seen, Space Force, you're waiting to watch it, and you know, I'm not really going to give a plot, okay? But so I wanted to let's look at this one little scene. I'm not really going to show anything. I'm just going to scroll through it. So these are some people. Okay, check that out. Yay! So this is perfect for a video analysis. So the nice thing here is a couple things. One, the camera's not even moving. It's not zooming or panning, so it's going to make our analysis really easy. People are moving up and down, perpendicular to the direction of the camera. It's perfect for video analysis. So the first thing I like to do is to take this and just kind of look. Who do I want to look at right here? I'm going to pick this person right here. I don't know why. The one that spins around. Okay, so I'm going to take that person and get the motion of that person in the air and see what kind of... maybe they're really on the moon. Maybe they are. Maybe, right? This person back here is very interesting too because they're not even trying. Look, it's like I'm on the moon, like whatever. I'm going to jump. Okay, so that's the first thing. The next thing is let's talk about the physics really quickly. So suppose I have... this is for projectile motion. Suppose I have a ball thrown in the air like this and it goes... the key thing is that there's only one force acting on it, the gravitational force pulling down. That'd give it an acceleration in this direction. I should have labeled that A instead of G, but whatever. And so then I have this object moving. It has a velocity. In any second, you could break it into an X component of the velocity and a Y component of the velocity. In this particular case, the astronaut is mostly just moving up and down, so it makes it a little bit easier. But here's the deal. If the object has a constant acceleration, then this equation would apply. This says that the position as a function of time depends on the initial position plus the initial velocity times time plus 1/2 times the acceleration times time squared. So I can, if I fit the motion of this in the vertical direction, the position as a function of time, it should be a quadratic equation in time like this. So here we get to the following. There are actually 3 things in a video. These are the 3 things. See, I'm moving them right there. 3 things. Okay, so the first is the frame rate. This is how, when you click on a frame and then you click on the next frame, the frame rate tells you how much time elapsed between those 2 frames. In usual cases, that frame rate is going to be reflecting on reality. So if it takes 1 second to move in the video and you wanted it to move in real life 1 second, then those would match up. Okay. Now, that's not always true. If I have a slow motion shot on the Matrix, then the frame rate is not the real time rate. So you'd have to take into account that. The next thing I have is the scale. How big is 1 pixel in the video? I need to set that. I need to find out what that is. And finally, if it's moving vertically, I have the vertical acceleration. So it turns out that if you know 2 of those things, you can find the third. So if I know the frame rates in real speed, and I can find the size of a person or just estimate, then I can use that to calculate the acceleration, and that's what I'm going to do. Now, one more thing. Once I fit a quadratic equation to the data up here, I get the term right here in front of the t squared term. The term in the coefficient in front of t squared is 1/2 the acceleration. So if I multiply that by 2, I would get the vertical acceleration. Let's get to it. So I've already loaded up the video in my favorite video analysis program. This is Tracker Video Analysis. Yeah, move right down there. Tracker Video Analysis. It's free, runs on everything. You should get it. So the thing I'm going to do is I cut a part of the clip out, but I didn't get it perfectly. So I'm going to scroll forward. See, I don't want to analyze that. And right, I'm going to include right here. So this is the person I'm going to be looking at, and I'm going to include the jump too. So you can move the beginning of the video by moving that thing, or right here it says 127. That's the frame number. So I go up here and I set the start frame to 127 and I click OK. And that just means that I won't get anything before that. Now the next thing I need to do is to scale the system. I also like to put down this is the XY axis. I'm just going to put it over here. I don't know why. So I'm going to go up here to click this new calibration stick. So, can't do that yet. So let's actually go forward. I'm going to use the size of this person to scale this thing. So if we skip forward, I think that's the captain. I can't remember her name. Captain something. Right there, she's standing up straight. And I'm just going to assume she's, 5'10" or 1.8 meters tall. Okay, I'm just going to make that assumption. So I'm going to go down here and shift click on her foot, and that will mark a point. And in fact, let me zoom in a little bit, 200%. I'm going to shift click down here, and then I'm going to shift click up here at the top. And now you see I can move it even. Let's put this right there. And it says some number, doesn't really mean anything, but I'm going to put 1.8. So there, I've scaled the system. And since the camera doesn't change how it moves, it doesn't really matter if I need to change that at all. So I'm going to go back to the beginning, and I'm going to actually mark the jump like I said. And I could pick some, there's a problem here, but I'll tell you about it in a second. I'm going to choose a new point mass, and I'm going to click on the top of her helmet and just mark the top of her helmet. Let's do that. So I need to hold down the shift key, and I'll just click, and it moves forward a frame. She's actually squatting down a little bit. Let me zoom in a little bit more. And then it doesn't have to be perfect because, I'm just going with the top. It's not perfect, but I can do it quick. So what you want, humans are not point masses. They're not rigid objects. So marking the point of the helmet doesn't actually work because you can move up in the air, and if you move your legs, it actually changes your center of mass. Your center of mass is what you want. So the best thing to do would be to approximate the location of the center mass. When she has her legs bent up, the center mass is going to be higher in her body. In this position, the center mass is right around the middle of the body. But I'm just going to mark the top. I think it'll be good enough. And let's get that done. I should tell you a story while I do this. Something about the moon. I don't know anything. I did like Space Force. Enjoyed it. Looking forward to season 2. I should say that, of course, they're not really on the moon because their spacesuits on the moon. There's no air. So your spacesuit, in order to keep the pressure, air pressure at a reasonable level that you can live at, has to be inflated. And it makes it hard to move your legs and arms. And that's why they look all puffy and so forth. This also makes it difficult to move on the moon because as you bend your legs and you bend your arms, that actually decreases the volume of air inside the spacesuit. So you increase the pressure, and you actually have to work against that. So what you want to do, it wants to be in just a arms out position that occupies the most volume. So they do make a thing called a constant volume suit. And touchdown. Nope. She touchdown yet? No. A constant volume suit has a rigid body, and it has joints such that when the arms or legs move, it just rotates the joints. Did she touchdown? Okay, she did. Okay, that's it. So this is the X motion. Okay, but I want the Y motion, so I'm going to go over here to click to Y position. And actually, look, that's a nice parabola or parabola. Now, I want to fit a quadratic equation to that, so I'm going to right-click and go to Analyze. And this will pop up a new window. Now, this is the jump part right here. I don't want that. I just want the other stuff. So let me scroll this down a little bit so I can have room. And now I'm just going to highlight this stuff. That's the part I want to analyze. And go over here, Analyze, Curve Fit, and it fit a line, but I don't want that. I want a quadratic equation, so parabola, and there you go. So this is the thing I want right there. Oops, that was weird. 10%. What did I do? Let's see. Let's see if I can refit that. It was at 0.5. No fit. Let's see, line. Go back to parabola. Is that right? No, see, it's not doing it. I messed up something bad. I don't even know what I did. How did you delete the fit? Refresh. Well, it was like around 0.5. I don't know. I'm really weird. Okay. Let's see, fit that. and this 10%. I don't even know what I did. It was at 0.5. It's somewhere around there. I'm just going to go with that, even though I messed up. Okay. So if I multiply that by 2, I get around 1 meter per second squared. So this is actually very reassuring. The actual acceleration of an object in free fall on the moon would be, I think, is 1.6. So, but that's close. I mean, I think I'm really happy that this is a parabola. So let's go back to the video. So how do you think this actually was filmed? I'm going to guess, you could do CGI, right? You could just say it's completely all people, not even real people. I don't think that's true. I think that they have strings pulling them up and with counterweights. And so a counterweight pulley system allows you to decrease the net force on a person. And so when they jump, they do have a constant acceleration jump. You could just have someone pull up and then let go and go down, moving up and down with a constant velocity. But I think that's what happened. They have a pulley system that changes the net force and thus the acceleration to somewhere around 1 meter per second squared. Now, you could adjust it and make it exactly like the moon, but then they wouldn't be in the air. It's artistic reasons why you may or may not want to do that. So maybe they said, hey, we don't care, it's close enough. Or maybe they said, we want that person to be in the air off the ground for a longer time. Now, what would be fun to do, and this is what you should do, look at this guy over here. Okay, you'll need to rescale the video because that person's further away. So the motion right here is different than the motion over here. But does that person also have an acceleration of 1 meter per second squared? What about the other people? Okay, so you can go check that. It'll be fun to do. But there's a little tutorial on video analysis. Hope you enjoyed that. Yeah. I guess we'll do some more physics later. I'll see you.